Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. This is the first session for AE 240, section 2. What I will be doing here, I'd like to welcome you all to this course. I'd like to get to know you. We have some time. This is what I did with section 1 on last Monday. Then I'm going to introduce the syllabus. I'm going to introduce the course, what are we going to do in this course. And we're going to touch on chapter 1, which is basically an introduction. This will become clear as we go through the presentation today. So I'd like you to go one by one, introduce yourself, and I'd like to hear from you about what you expect from the course, or whether you have a concern on the course, whether you have heard something from your colleagues from the course, so that I can address this in the introduction that we're going to have. So I don't like to introduce myself first. I'd like you to introduce yourself and your expectation, your aspiration, your worries about the course, about the distance learning environment, about anything that comes up to your mind. Okay, so since we don't have so many students here today, that should be an easy task. So let's start with Badr. أيوة بدر. Hello. طيب, until Badr join us, let's see فيصل.
أهلا يا دكتور.
أهلا يا فيصل.
First of all, my name is Faisal Al-Shihri.
أيوة.
And I expect from this course we will take a project about airplanes and how we make a project that contain from A to Z how we can do let's we say contain all the airplane that we need in this course. So
okay. Okay. Great. Let me accept you. So I'm going to address some of the words that you mentioned now in the introduction. Let me first accept your colleagues. We have 5 colleagues who want to join us now. Just a second. And let me accept them. Oh, we're having even more coming. I have 9 requests, but I can see only 5. Where are the other 4? I accepted all the requests that I have, but still some of your colleagues say they sent the request, but I don't see any more here. Okay, I think we'll continue with what we have, and then they can catch up with us. So I don't have any more requests here. Okay. Okay, next, Mohammed Al-Ali.
Yes, can you hear me? Can you hear me, Doctor?
I can't hear you, Mohammed. Yes, I think it's coming this one.
Okay. Can you hear me now?
Mohammed?
Dr. Wang.
I can't hear you. I think you check your mic. Oh, you hear him? Then it must be me. Let me check my speakers. I think I can. Okay. Okay, Mohammed.
Okay.
Yes. So
Yes. I think we are going to study in 220. We studied the principles of aeroplanes and principle of engines and many other things.
yes.
I think in this course we will study how to design the plane.
The plane.
Maybe the wings of the plane. We studied it theoretically.
Okay.
But now I think we are going to take more advanced topics on the design aspects.
Tamam. Okay, I'm gonna again elaborate on this because it's not quite as you expect. So it's good to establish our expectations right from the very beginning. I'll do this in the introduction right after I hear from Badr. this time I really don't hear you. I'm not sure. Anyone hears better? Oh, okay. Okay. So we hopefully next time you will fix that, because we're going to be asking several questions. Okay, so I'm going to share with you the introduction, which should introduce everything that you need to know about our course. Okay, so for 201, my name is Wael Abdurrahman, and inshallah, right after the COVID-19 situation, I'd like to see you popping up for questions. My room number is 75112. I already posted material on Blackboard. I'm not sure if section 2 have access now to Blackboard. Do you? For the course?
No, not yet.
Not yet. Okay. Once they give you access, please log in. Right now, I posted on section 1. If they give you a separate site, I'm going to post that there too. What we have is the syllabus, so I'll go quickly over it this time. And some useful material, introductory message that will set our expectations. Also, there is a WhatsApp group. I'm sure since you are here now, you have seen the message where we have that link to the WhatsApp group. It's also a good idea to have a second channel for communication if you have a quick question, rather than writing an email or writing it through Blackboard. So feel free to use it anytime. Okay, right now this group is for both sections. I think it will remain this way because I assume questions for one section is also useful for the other. Okay, so we have a textbook. I think FUPM sent you like a schedule or something to pick your textbook if you are close in the Eastern Province. I'm really not sure what's going to happen for those of you who live in other provinces. Did they tell you? Were you informed what they're going to do with textbooks?
Yeah, they can take the university will email the textbook to them.
Great. So it will be sent by mail. Hopefully, maybe early next week, you will have the textbook. So meanwhile, we are gonna use the slides. If you have a PDF version of the textbook, that would be fine until we get the textbook next time. So John Anderson's textbook is basically a performance book, aircraft performance, and you're gonna understand why as we go into the topics that we're gonna cover. And with a slight taste of design at the end, because it's a sort of an introduction to aircraft design. The main course of aircraft design is AE427, in which the textbook is Raymer's book, Aircraft Design. Now, for your case, that book is going to be like a reference. It's not a textbook, but it's just a reference where we're going to use small pieces here and there from that particular book. So you have one textbook, the John Anderson's book, Aircraft Performance and Design, and another reference, which is Raymer's book, Aircraft Design. Okay. Also in the syllabus, I posted so that you know from day one how it's going to be in a distance learning environment. The grading system is based on the assumption that we will continue, la qadar Allah, online for the remainder of the semester. If things, inshallah, change after week 7 and you're asked to come to school and conduct exams and so on, parts of this grading system is going to change a little bit. Okay. So attendance and participation, we have 10%. You can see the slides?
Yes.
Okay, so attendance and participation, we're having 10%, and I can take the attendance anytime after 9:05 every day, anytime. And I'm not going to be calling attendance, so I'll just even, depending on the numbers, I can call the name, or I can just ask teams to store the attendees list. Then we're going to have 5 assignments, roughly after every chapter, not quite every chapter, but after most chapters. We are going to have 5 assignments totaling 10%. 3 quizzes, 5% each, strategically positioned after certain chapters. So maybe every 2 chapters we're going to have a quiz. Then we're going to have midterm exam, typically in week 7. Right now, the plan is that we're going to conduct it online, unless things change. Then starting the second half of this semester, maybe from week 8, we're going to start our design project. There are design project tasks totaling 15%, roughly 3 tasks, and every task would take about a couple of weeks. Okay, so you will be divided into teams. Each team will conduct a task, will conduct 3 tasks. Okay, and you will learn how to divide the work amongst yourself as a team. Towards the end of the semester, on Monday of week 15, we're going to have, on Monday of week 15, we're going to have to submit a project report, which amounts to 10% of the total grade. After submitting the report, and on Wednesday of week 15, inshallah, you are going to have to make a single presentation for your project. It's for the whole team is going to make a presentation, which worth 5%. Then we have a 5% for a final oral exam if situation remains online. And finally, we are going to have a final written exam, 20% of the grade in the exam period. Okay. Now, I don't want to keep talking, so please feel free to interrupt me anytime you have a question. I will address the items that you mentioned when we get to the parts of the topics and the project as we go. But if you have any question, feel free to interrupt. We don't have so many students today, so we can accommodate that. Okay.
Clear.
So let's go on with the course outline. The textbook that we have has 9 chapters, and these chapters are classified into 3 parts. Part 1 is basically an introduction, which is chapter 1, chapter 2, chapter 3. So it has an introduction, like historical introduction, as you had in 220. But we're not going to take like the history of aircraft, but we're going to focus on the improvements that were pushed by innovations in design. So we want to see what did designers do to improve aircraft. Then we're going to have a quick look at the aerodynamics of the airplane in chapter 2 and different engine types in chapter 3 of propulsion systems. So in these 2 chapters, we're going to pick and choose parts from the relevant chapters in AE 220. So these 3 chapters, I consider them like an introduction or the basics or the layout for the aircraft. Then we're going to study the performance of the aircraft in 3 chapters. Chapter 4, equations of motion, and chapter 5 and 6, the performance of the aircraft. And the reason why this is arranged like this is that we want to make sure that we have the proper foundation, chapter 1, 2, 3. Then what are the motivations for the design, which is improvements in airplane performance. So we must understand what's the performance, how to quantify that. Again, this is very much similar to what you had in AE 220 with a little twist. We're changing it a little bit. After understanding all of this is around week 6, okay, or 7, week 6 or 7, depending on how we're gonna progress. Then we're gonna study the design of the airplane, the steps of design of the airplane, and that's covered in chapter 7, 8, and 9. Chapter 7 is the general layout. Chapter 8 is for jet aircraft and propeller aircraft, and chapter 9 is for jet aircraft. Now, I'm sorry to tell you that we are not going to have the design from A to Z, as one of you mentioned. In fact, we are not going to do this even in AE 427. It's beyond the scope of any design course in any university. Okay. What we will be studying is what we call the conceptual design. And the word is very misleading because typically a person would think conceptual design is just a sketch, an imaginary drawing, or no. Conceptual design involves a lot of calculations, basically the shape, the dimensions, everything in the aircraft is set to a certain level of detail, not to the finest detail, but to a certain level of detail. Okay. And we're going to understand what does that mean when we get to chapter 7, where we're going to start doing the design itself. Okay. In AE 427, we're going to do one complete cycle of design. And then we're going to proceed to see what should be done next. Stuff that cannot be done in a university, stuff that can be done in a company. If we're going to have marketing of the aircraft, if we're going to have detailed design of components, assembly drawings, manufacturing, testing, and so on. Okay, so basically, think of it, I'd like to think of it as a performance course, but it's aimed towards the design of the aircraft and giving you the necessary means for the more comprehensive course, AE 427. Okay. Questions?
No question.
Okay. So I hope this give you a perspective of what we will be doing. We are going to have introduction, propulsion aerodynamics, then we're going to have performance, equations of motion, performance object, and the propeller. Then we're going to have the design. I'm going to go quickly over the parts that you had AE 220, which at some point, if you feel that I'm going too fast, please let me know. I assume that you still remember what you had in AE 220, but I don't mind reviewing parts here and there as we go. Okay, so let's start by seeing how did design affect the development of the aircraft. So before we get in there, let's first agree what do we mean by an aircraft. Let's make sure that we all use the same term for the same meaning. When I say an aircraft, how can you define that? Because depending on the definition, things are going to be different. So what's an aircraft? Let me ask you blatantly, what's the aircraft?
What's what, Victor?
How do you define an aircraft? When we say an aircraft, what do we mean?
It's a kind of vehicle that can fly.
Okay. So that covers balloons?
What?
This covers balloons, right?
Yeah, it might be.
The definition covers balloons, but balloon is not an aircraft, so it doesn't fall in. So that definition is a little short, right? Because when you say it can fly, well, balloons can fly. So do we consider it an aircraft? No, a balloon is not an aircraft. Okay, so try again. What's missing in your definition so that it's valid only for aircraft that we have?
Maybe it is a reusable craft. We can, I mean, the rocket is not an aircraft because it's not reusable.
Okay.
Also,
SpaceX did one that's reusable. So does that mean it's an aircraft?
no.
Okay, so it's not reusability. What's missing? There are several items that define an aircraft. What's the difference between a balloon and a real airplane?
It the airplane generates its own energy to fly.
So that's a keyword. So when you say an aircraft, we are talking about vehicles that fly under their own thrust. Okay, So they are powered aircraft. It's powered flights. Okay, so that term is very important. That's why we have a whole chapter on propulsion. So that's one keyword. It's not the only keyword, but it's one important keyword that has to be there. Powered vehicle that fly. What else? Now, according to this, we are still missing something. Because if you throw a missile, it's powered, it flies, and it's a vehicle, but it's not an aircraft. What else is missing?
Maybe
You can write better if you have a problem with the mic, you can write better. I can see that. Okay. What were you saying? You added something, right? Okay, so let me have wings. I would say so, but what about quadrotors? They don't have wings, and yet they are aircraft. Okay? So it's not only about the wing. Winged aircraft is a huge category of aircraft, but it's not the only one. Okay. So let me complete the missing words that you have in the definition of aircraft. An aircraft is one. Let's go back to our presentation here. An aircraft is a heavier than air machine. First, it has to be heavier than air. It does not depend on buoyancy forces to fly. It's not like a balloon. So it has to be heavier than air. When we say aircraft, it's a heavier than air vehicle that's capable of powered flight. So it flies under its own power. And the last missing keyword is that it's controlled flight. So it achieves controlled flight under its own power. So it can change attitude, it can change direction, it can go up, it can change down. So it is controllable, it is powered, and it flies in the air, and it's heavier than air. You see, this definition encompasses the 4 disciplines of aircraft that we have. We have the control, we have the propulsion and powered, we have fly in the air, the aerodynamics, and then we have the structures in the fact that is a vehicle that includes all of this, and that's heavier than air. That's the keyword. Okay, so that's the structures part that we have in here. Why I'm saying this? Because before 1903, people actually used to fly, but they had no aircraft. So they were flying by gliders, which is not an aircraft. So a glider is not an aircraft because it doesn't have the power. They try to fly by flapping wings. We call this ornithopters. They failed miserably. So no ornithopter worked actually, like the one of Leonardo da Vinci. They tried to have gliders like the one by Sir George Cayley or by Otto Lilienthal. All of these failed. These were not aircraft. They were flying objects, but they were not aircraft. The first aircraft to achieve the 4 components was the Wright brothers flying machine. They had in 1903. So you have the control, you have the power, the propulsion, you have the structure, the fact that it's heavier than air, and then you have the aerodynamics. It actually was flying. Okay, so that's very important. Keep these 4 items in mind as we go in the design. So a UAV that can work as a flying missile, for example, is still an aircraft. although it's not reusable. It will explode once launched at the end, but it is an aircraft because it has the 4 components of the flight. On the other hand, a balloon is not. Okay, a dirigible like all the different Zeppelins that were there by Germany before World War II. These are not aircraft. They had the propulsion, they had the control, but they were lighter than air. Okay, so they don't count as aircraft. We don't design dirigibles. We don't design balloons. Okay. So what happened after the Wright brothers flew their aircraft is that people started to think, okay, let's design a structure that's strong enough to carry the engine, strong enough to host the controls. So they came with what's called the biplane. A biplane basically is a twin wing plane, one on the top of the other. So in a biplane, we have a cantilever. Hopefully you are taking either CE 203 or 201, so you know what I'm talking about. So it has a beam on the top, a beam on the bottom, and then we have struts and wires in between holding the structure and making it a strong structure. Okay, so almost all aircrafts at the beginning of the century up to 1930 were biplanes. Aircraft of World War I were biplanes and so on. Okay. Toward the 1920s, the innovations in design were powered by races. So there were different important races all over the world, and people compete to win these races. And in their competition, they improved the designs. So we had the engines becoming bigger and bigger, stronger and stronger. This is one aircraft that won the Schneider. It's a famous race called the Schneider race. It was designed by Curtiss, and he established his own company. Then we had a Supermarine, which won that race 3 times, and so they kept the trophy for themselves, just like the soccer trophies. So they kept it for the company. And this aircraft evolved later. Its design improved, and by World War II, it became the famous Spitfire, the British aircraft. Okay. And towards the end of that era, people started to explore the single wing. It's called monoplanes or single planes. Instead of the biplane that we have here, they start to explore the monoplanes. Now, why do you think people started with the biplanes? Why do you think the history of aviation started with biplanes? Why do you think that?
Maybe because it generates more lift.
Well, if I have a wing that's double that span, a single wing, double that span, I will get the same lift with a single wing. So I can remove these 2 wings, one on the top of the other, and make a big wing, a long wing with a long span that will generate the same lift. So what do you think was the problem in that?
Maybe it will have a lot of torque that will cause the wing to bend. Because it's
do you call it? Yeah, that's close to correct. Do you call it torque or do you call it bending moment? It has a lot of bending, right? The lift is going to bend the wing upward. Because it's a very long wing, it will tend to bend upward. The shorter the wing, the less is the bending upwards. Not only this, by having 2 wings, one on the top of the other, and connecting them with the struts, we are basically making something like a box, which is stronger. So basically, aircraft started as biplanes because of structural issues. Okay, they had a stronger structure, and we didn't have strong materials that can make a monoplane. With improvements in material in between the 2 world wars, aluminum alloys started to evolve, allowing the introduction of monoplanes. Not only aluminum alloy, even wood designs, improvements in designs of wooden structures made the use of monoplanes possible. Okay, now there are other innovations that became very normal during these days. One of them is the cowling for the engine. You see, older airplanes had the engines exposed to the air. Okay, but NACA developed a set of experiments on different types of cowlings, proving that they reduce the drag. So newer modern aircraft started to use these cowling covers of the engines. Okay, improvements in the fuel, improvements in high lift devices. So here is the introduction of the cowling to cover the engine and reduce the drag. So it became here like commonly used in aircraft in between the two world wars. The older ones didn't have cowling. You can see the engines here completely. Retracting the landing gear, improvements in control surfaces. And by improvements in control surface, the use of flaps, trailing edge devices, or slats, the leading edge devices. Why? I assume you had this in chapter 5 in A20. Why do you use flaps? I don't want just one of you to keep answering. Okay. Let's hear a new answer. Why do you use flaps, high lift devices? Let's see. Badr, can you write it? No? You know what? Okay. Yeah, I'm asking, why do we use high lift devices? They're called high lift device because they increase the lift, right? So if I don't have any flap or slat, the lift could be 1.5. If I use a plain flap, it will increase to 2.4. Then it will increase if I have a slotted flap, and it will increase even more if I have more complicated flaps. So with the introduction of flaps, it was possible to increase the lift coefficient. And this is very important to increase the load factor on the aircraft, to allow the aircraft to conduct maneuvers of high lift. So that pushed towards the use of these flaps in aircraft of World War II. Think of the aircraft, military aircraft of World War II as like the end of the piston engine era and the starting of the jet engine. Aircraft like the Lockheed P-38, the Torpedo aircraft, Republic P-47, and the fighter P-55 Mustang as the ultimate propeller aircraft that were flown. And they started to push the limit of speed so that the use of piston engine is no longer a possibility. So came the jet engines. Jet engines were introduced with the required increase in speed. They were introduced separately in England and Germany by two major engineers and scientists. They allowed aircraft to break the sound barrier. The first to break the sound barrier was Chuck Yeager or Charles Yeager, who was a test pilot. And then aircraft speed increased and became like Mach 1, 1.5, 1. And with the increase in this came innovations and changes in the design. So we are tracking now the changes in the design based on the performance of the aircraft. So the main change in the design that was pushed by the increase of speed was the sweeping of the wing. Swept wings mean pushing the wings backward and allowing them to reduce drag at higher Mach numbers, basically in the transonic and the supersonic regime. Okay. And innovations in design continued. For example, we had pressurized cabins when aircraft were able to fly higher, above 8,000 feet, where passengers would be unhappy with an unpressurized cabin. You need to provide them with air that's close to the air pressure at sea level. So we had the first pressurized cabin in the aircraft de Havilland Comet, which basically the first jet airliner. Okay. The Comet had several catastrophic structural failures, 3, and the program was terminated because of these problems. People back then did not understand quite well the issue of metal fatigue, which was the main cause of failures of such pressurized cabins. Because when this aircraft go up, you pressurize, you fill it with air. Then when it go down, you depressurize, you take the air out. Pressurize, depressurize, pressurize, depressurize. That would put a lot of alternating stress on the skin of the aircraft. And if you have a crack or a notch on this skin, it will just get bigger and bigger and bigger until it causes catastrophic failure. Okay. Why I mentioned this? Because we are going to worry about fatigue when we start designing the structure of the aircraft. Okay. Other innovations in the jet era are the inclusion of pylons. Pylons are the houses of the engines that connect them either to the wing or the fuselage. And they are shaped in an airfoil shape just to reduce, or they have similar to an airfoil cross-section, slender cross-section, smooth cross-section in order to reduce the drag. Okay. Then we had supersonic aircraft, both in the civil and aviation and military fields. So of course the Concorde was the first supersonic transport. And improvements in the design continued. Now, basically what you're looking at here is the typical aircraft. When you say an aircraft, that's the shape that we have that encompasses the 4 elements: heavier than air, the structure, the powered flight, the engine, the controllability, the control surfaces, and the flying ability of the aircraft. Okay, but that doesn't mean these are the only shapes of an aircraft. We have different ways. Innovation never stops. So we have different variations of an aircraft. We have aircraft that still have wing, but they don't take off and land horizontally. They take off and land vertically. So we have the British Harrier taking off vertically. We have aircraft's peculiar designs in order to reduce the drag. Engineers decided, let's take the fuselage out, let's reduce the area of the tail, and they came up with a flying wing, because essentially all the aerodynamicists need to fly an aircraft is the wing. If I am the aerodynamic guy in a team that design an airplane, I really don't care about the structure or the fuselage or the tail. All I care about is the wing. It's what carries the aircraft. So they decided, let's have a flying wing like this one, only to find out that it has a stability and control problems that were not solved until recently, when computers were introduced on board the aircraft to control. A flying wing is essentially uncontrollable, although it flew, but it cannot be properly controlled. And if you look at earlier videos of this aircraft, you will see that it was wobbling right and left. That's the best the pilot can do. But with onboard computer controls, flying wing fighters and bombers were developed. So we have the F-17 or F-117 fighter, as well as the B-2 stealth bomber. Stealth capability was introduced using composite materials, and the objective was to reduce the radar cross-section. A radar cross-section is, think of it as the fingerprint of the aircraft on radar screens. You want to make this as small as possible so that it can be confused with a flock of birds, for example. Okay. And so on. We have several innovations. We have aircraft with strange fuselage designs for a certain reason. For example, the Voyager was designed to fly all around the world, non-stop. So think of it as a flying fuel tank. It was essentially a flying fuel tank with a single person on board. Other designs would include improvements in speed when you want to fly above Mach 5. Okay, like the NASA's HyperX, which was a hypersonic aircraft. So I can keep on and on and on doing this innovation. The point that I want to come to is that based on exactly what you want to achieve in the design, then we're going to have a certain mindset, and this will lead us to the first sketch of the first draft of the aircraft where we're going to go in there. So design of an aircraft is mainly initiated by either a demand, something that you need to achieve, by requirements of a client. So a client would come in and want to design an aircraft that flies faster or slower or higher or at a certain rate of climb and so on. So the requirements are our starting points in the design of the aircraft. So that basically was chapter 1 of the textbook, the historical perspective of aircraft design. Okay, it was meant to give you to shed some light on the how improvements were done using design. Next time, inshallah, we're going to start on the foundation, basically the aerodynamics. So we're going to cover the aerodynamics part that we'll need in the design. Okay. So let me see if we have any questions. I didn't see any raised hands. Any questions, Ishwar?
Sir,
Yes.
there is some student, they have struggled to enter this meeting.
Yeah, I keep getting things, but I accepted all the requests. Maybe they did after we started or something. Let me see. I can't see here. Let me stop the recording since we're done here, and I will try to see what I can do for them to